So let's start today's session. Today we will talk about the previous year assignment question week number 12, and that will be the last class for nuclear and particle physics course 2023. So question number 1. Select all the right statements from below. Photon has 2 independent degrees of freedom, whereas Z boson has 3 degrees of freedom. Photon and Z boson each has 3 degrees of freedom. Photon and Z boson each has 2 degrees of freedom. Photon has 3 degrees of freedom, whereas Z boson has 4 degrees of freedom. So here we can see that among these 4 options, each and every option are connected with each other. So if A is correct, then B, C, D are not correct. And similarly, if B is correct, then A, C, D will not be correct. And in that question, they are asking that what will be the degrees of freedom for photon and what will be the degrees of freedom for Z boson. Now, let us start. Photon. For photon, what will be the degrees of freedom? We all know that photon is massless. There is no mass in photon. So, if photon does not have any mass, the degrees of freedom for this particle is 2. Why? One is transverse directional, and another one is longitudinal directional. So photon has 2 degrees of freedom as it is massless particle. If it is a massive particle, then there will be 3 degrees of freedom. As photon does not have any mass, so that's why photon has 2 degrees of freedom. Now coming to the Z boson. Z boson is how much degrees of freedom? So we all know that Z boson, it has a mass, and the mass is of the order of 90 GeV. So if it is massive particle, then as I told you, if it is a massive particle, then it will have 3 degrees of freedom. So for Z boson, degrees of freedom will be 3, and for photon it was 2. So in the summary we can write photon has 2 degrees of freedom, Z has 3 degrees of freedom. Okay, so now coming to the option again. In that first option, it has written that photon has 2 independent degrees of freedom, whereas Z boson has 3 degrees of freedom, which is exactly correct. Now coming to the B, C and D option, you can see that in B option, photon and Z boson, it has 3 degrees of freedom. Obviously not, because I already told photon has 2 degrees of freedom and Z boson has 3 degrees of freedom. Similarly, photon and Z boson each has 2 degrees of freedom. No, photon has 2, Z boson has 3. Photon has 3 degrees of freedom, whereas Z boson has 4 degrees of freedom. That is also not correct. So the correct option is A. So this is the first question. If you have any doubt, you can just ask me. Okay, we will go to the next question. This is the next question. The process E plus E minus goes to W plus W minus, whereas W plus minus denotes the weak case boson of mass 80 GeV by C square is not possible as mass of W plus minus is greater than that of electron, possible with sufficiently large kinetic energy for the electron and the positron, possible even with vanishing kinetic energy of the electron and positron, not possible because we have spin half particles in the initial state, whereas W plus minus in the final state are spin 1 particles. So there are 4 options, and they are asking that this process is possible or not. If it is possible, then in which condition it is possible? If it is not possible, then why it is not possible? Okay. So we will talk about first the interaction what is given here. E plus E minus going to W plus W minus. Now, I already told so many times that in any nuclear reaction, not only nuclear reaction, in any reaction, energy should be conserved, right? So, right now we will see about the energy. I mean, total energy should be conserved. Total energy should be conserved. Okay. So how to do that? Like, we have to check that one at the very first, that is it possible or not. So to check this one, we have to check that total energy of this system is conserved or not. First of all, the initial total energy. What will be the total energy for the initial case? So first of all, let us take one assumption that these E plus and E minus are in at rest. If it is in at rest, that means there is no kinetic energy, right? If there is no kinetic energy, then we can write total energy equals to mass of E plus mass of E minus only. So we all know that mass of E plus is 0.511 MeV, right? Similarly, it is exactly equal to mass of E minus. So if I calculate the initial total mass, this will be nothing but 2 into 0.511 MeV. Now coming to final total mass. We are assuming that the final particles are also in at rest. So total energy of W plus W minus will be similarly mW plus mW minus. Now it is already given here that the mass of the weak gas boson is 80 GeV by c square. So in natural unit, I can write mW plus equals to 80 GeV, which is exactly equals to mW minus. So we can see that total final energy is 2 into 80, that means 160 GeV. So now what is the conclusion here? The conclusion is in rest case. Rest case means when there is no kinetic energy of initial as well as final particle. Then we can see that the initial kinetic energy, initial total energy was 2 into 0.511 MeV, which is of the, let's say, of the order of 1 MeV, and E final was 160 GeV. Now you can see that the initial energy and final energy, there are too much difference, right? So in rest case, it will never possible the reaction. That means E plus E minus goes to W plus W minus will never be possible if it is in rest case. Okay. So this is the condition for rest case. Now let us take one second assumption, that there is a very large value of kinetic energy between E plus and E minus. So if E plus and E minus has too much kinetic energy, then our total energy, which is initial, that will be obviously E plus plus me minus plus kinetic energy of E plus kinetic energy of E minus, right? And we are also thinking the same assumption that W plus minus case, these are all rest. So that means for that case the total energy will be EF will be mW plus mW minus. Now you can see that if by anyhow kinetic energy of E plus kinetic energy of E minus is very large, then EI can be comparable to EF, or even EI can be very greater than EF also. So if EI is greater than EF or EI is very comparable to EF, then that means the energy is conserved here, right? So that type of nuclear reaction can be possible. So the second option will be the one where the E plus E minus going to W plus W minus can be possible, right? Now we are just coming to the option again. First option was not possible as mass of W plus minus is larger than that of electron. It is, but in the case of rest frame. But if E plus and E minus are not at rest, at that point E plus E minus going to W plus W minus can be possible. Whatever it is written here would be possible with sufficiently large kinetic energy for the electron and the positron. So this option will be correct. First option will not be correct. Now coming to the third option, possible even with vanishing kinetic energy of the electron and positron. It is obviously not, because we saw that when and only when there is a very large kinetic energy of E plus and E minus, in that condition only E plus E minus going to W plus W minus reaction is possible. So that means the D option we have to check right now. What is D option here? D option is not possible because we have spin half particles in the initial state, whereas W plus minus in the final state are spin 1 particles. So right now we will check this condition. Is it correct or not? In that option, what they have shown, they told that as E plus and E minus has the spin as spin half particles, that means for the W plus and W minus, as it is spin 1 particle, this reaction will not be possible. So let us just calculate is it correct or not. So see, spin angular momentum. So spin angular momentum also should be conserved in that reaction, right? So spin. So here the spin is half. Here the spin is half. And I already told that spin is a additive quantum number. Additive means it will be quantum mechanically additive quantum number. So quantum mechanically additive means, let's say our H1 is half and H2 is half. So our final H will be H1 plus H2. What is this sign? So let us know about this sign. So this sign is nothing but H1 plus H2 means it can have the value mod of H1 minus H2 to mod of H1 plus H2 in steps of 1. Okay. So here in that case H1 is half and H2 is half, because these two electron and positron both are spin half particle. So if it is like that, then our capital H will be half minus half, which is 0, to half plus half, which is 1. That means 0 and 1 will be the correct one. I mean the combined spin will be 0 and half, 0 and 1. Now coming to the final H. Final H was what? W plus W minus. So W plus W minus are spin 1 particle. So that means H1 is 1, H2 is 1. Now in that case, we are talking about H, which is 1 minus 1 equals to 0 and 1 minus 1 plus 1 is 2. That means 0, 1, 2. These three are the possible values. Now you can check that As our initial spin was 0 and 1 and the final spin is 0, 1, 2, that means this, I mean, with seeing this condition that 0, 1 is there and 0, 1, 2 is also there, we can't say that E plus E minus goes to W plus W minus is not possible, because this is satisfying our spin and angular momentum conservation. So whatever it is given in the D option, that not possible because we have spin half particles in the initial state, whereas W plus minus in the final state are spin 1 particles, it is not correct. That statement is not correct. Even if the spin of E plus E minus is half and W plus minus is 1, in that case also we can have the reaction. Okay. So the correct answer for this question will be D. I think it's understandable. It's very simple. I have just explained a little bit more here. Okay. So coming to the third question. In the third question, particle X decays to two particles, A, B. That is, X is going to A plus B. If X and A are fermions, B is necessarily a fermion, could be either a fermion or a boson, is necessarily a boson. So there are three conditions. What is the question asking? The question is asking like X equals to A plus B. In that case, X is a fermion, A is also a fermion. Then what about B? B is a fermion or boson. So we have to check that. How to do that? First of all, it is very much well known that in any nuclear reaction, three things should be conserved: L, B and Q. Lepton number, baryon number and charge. So these three things should be conserved in any nuclear reaction. As X going to A plus B, this is also a nuclear reaction. So we have to check that these three should be conserved in this reaction, right? And also we can also see that the spin angular momentum quantum number should also be conserved. Now coming to the condition that X is going to A plus B. I told you that X is a fermion, A is a fermion, right? So if fermion is there, fermion means what? Fermion means, let's say it is a lepton, it can be lepton or it can be baryon, right? So I am just talking about first lepton number conservation. Let's say it is a lepton, this is also a lepton, let's say, okay? If it is a lepton, then our lepton number should be conserved. Lepton number should be conserved. That means this one should not be a lepton. Otherwise, lepton number will be violated, right? So, let's say if it is fermion, if I am just talking the first assumption that it is fermion. If B is fermion, fermion means it can be lepton or baryon. Let's say it is lepton. At that condition, lepton number will be violated. Because here is lepton, here is also one lepton and here is another one lepton. That means the delta L is not equals to 0. Now take the second assumption that it is a lepton, this is a baryon, this is not a lepton. And in that case, this is a lepton. So for that case, you can see that the lepton number is conserved. That means there is one lepton and here is also one lepton. But the problem is in baryon number. You can see that there is extra baryon is coming because A is a fermion, right? So that may be a problem. So B cannot be a fermion. If B is a fermion, then lepton number or baryon number, one of them can be violated. Now just take the same thing in respect of spin angular momentum conservation. So if it is fermion, then fermion means what will be the spin? The spin will be half. If A is fermion, then what will be the spin? The spin will be half. Then what about B? If it is fermion, then let's say it has spin as half. Then just right now we told about H1 and H2. So S will be, for this case, as this is two particle product, that means in that case H1 and H2 will be like half minus half, 2 half plus half, right? So that means it will be 0, it will be 0 and 1, right? So if it is 0 and 1, then you can see that the left hand side is half, which is not actually correct, because in the right hand side you can see that the spin is 0 and 1, and in the left hand side the spin is half. So that means the spin is not conjugate if our B is fermion, right? Now let's say B is boson. So if B is boson, that means what will happen? If it is boson, that means there will be integer spin. Let's say I am talking about 1, and this is half, this is also half. Then what will happen? Here you can see half minus 1, 2, half plus 1. Oh, sorry, half plus 1. Right. So for that case, you can see here the resultant S will have the value half and 3 by 2. And also you can see that in the initial case the spin was half. So that means the spin angular momentum quantum number will be conjugate here. Okay. So obviously we can tell that whatever the B is there in that question, it will be boson, not fermion. Okay. Yeah. So in that question, as it is given that particle X decays to two particles A, B, that is X is going to A plus B. If X and A are fermions, B is necessarily a fermion. It is not correct. B could be either fermion or a boson. It is also not correct, because in that case spin momentum quantum number will be violated. B is necessarily a boson. That is correct. That means the correct option will be C. Option number C. Okay, so if you have any doubt, you can just ask me, or otherwise we will go to the next question. Okay, so next question. Question number 4. Which of the following processes are solely mediated by W boson? Choose all correct options. And there are 4 options. So we have to check that which one is the correct one. Mu plus nu E bar going to E plus nu mu bar. Mu plus mu minus going to nu E bar. E plus mu plus E minus going to nu mu bar. And mu plus mu minus going to E plus E minus. So these 4 options, among these 4 options, which one will be the correct one, that this process is solely mediated by W boson? Okay, so we'll check that. First of all, we are just going to do that one by one. So first one is mu plus nu E bar. It is giving us E plus nu mu bar. Okay. So for that condition, first of all we will check that this process is allowed or not. If it is not allowed, then there will be no talk about that it is mediated by W boson or not. So if it is allowed, then only we will check that it is mediated by W boson or not. So first of all, how to check that? As there is neutrino, I told before also that as it is neutrino is present in that nuclear reaction, that means obviously it will be a weak interaction. And for weak interaction, there are only 2 conditions to have the weak interaction. First one is L, B, Q, these 3 will be conjugate, as already it is applicable for all of the nuclear reactions. And the second one is Le, L mu, L tau, these 3 will be conjugate independently and separately. Okay, so Le, L mu, L tau, these 3 should be conjugate independently and separately. And another condition is that lepton number, where baryon number and charge should be conserved. Now we will check that is it conserved or not. So this is the expression, right? Now coming to lepton number. In that lepton number you can see that the lepton number is minus 1, minus 1. This is minus 1, this is minus 1. So delta L will be 0. Coming to baryon. Obviously mu plus mu mu, E plus mu mu bar, all these 4 are not baryon. That means the baryon number will be 0 for each and every case. Then also we can have delta B equals to 0. Now coming to Q. This is plus 1, this is 0, this is 1, this is 0. So delta Q will be 0. Right. Now we will check LE, L mu and L tau. Okay, so LE. So LE is what? It is electron type lepton number. So for mu plus it is 0. For mu E bar it is minus 1. E plus it is minus 1. This is 0. That means delta LE is 0. Similarly for L mu it is minus 1, 0, 0, minus 1. That means delta A mu equals to 0. Now coming to L tau. As mu plus mu E bar, E plus mu mu bar, among these 4 there is no one as tau type lepton. So we will simply write L tau as 0. So this is also possible. Now you can see that these all conditions are satisfied. That means this expression mu plus mu E bar going to E plus mu bar, this is possible. Now if it is possible, then which one will be the mediator for this case? So as it is a weak interaction, for that weak interaction the mediator is W plus W minus Z0, right? So we will talk about these 3. Now if I draw the Feynman diagram for this, then the Feynman diagram will be like mu plus mu mu, mu plus mu bar, then nu E bar, E plus. So you can see in that vertex plus 1 is coming, 0 is going. So if plus 1 is coming, 0 is going, so in that vertex if charge should be conserved, that means in that mediator there will be one charge particle, and among W plus W minus Z0, which one is the charged one? W plus W minus. That means W boson is charged one. So for that case W boson is charged particle, that means W boson will be the mediator here. Similarly for this vertex also you can see here the charge is 0, here is plus 1. So that means obviously there will be one which is going out and its charge will be plus 1. So mu plus nu E bar going to E plus nu mu bar, that should be solely mediated by W. Otherwise if there will be Z, then this vertex will not be the correct one due to the charge conservation. Okay. So the option A is solely mediated by W boson. Now coming to the B option, mu plus mu minus mu E bar. Mu plus mu minus mu E bar. So as I told you that mu E is there, that means it is a weak interaction, and in weak interaction L, Q, B, L E, L mu, L tau, these should be conserved. So we will quickly check that. L plus 1 minus 1 plus 1, 1 minus 1. B 0 0 0 0. Q 1 minus 1 1 0 0. Fine. Now LE. So LE will be here 0 0 1 minus 1. L mu will be 1 minus 1 1 0 0, and L tau is 0 0 0 0. show all the terms L, Q, B, Le, L mu, L tau, these all are conserved under this nuclear reaction. So this nuclear reaction will be allowed. Now coming to the Feynman diagram. What will be the Feynman diagram for this case? In that case, if I draw the Feynman diagram, then let's say I am drawing this one. Mu plus, mu minus, nu E bar. Now you can see that in that vertex, plus 1 is coming, minus 1 is coming. So whatever will be the mediator, that should be neutral. Neutral means Z. Here also from Z here to here, this is 0, this is 0, this is 0. That means the vertex is conserved under charge. So in that process, there will be Z as a mediator. There will be no W as a mediator. So whatever the option was there, that will not be correct one. Now coming to C option. E mu plus E minus going to nu E nu mu bar. Okay. Mu plus E minus going to what? Nu E nu mu bar. Nu E nu mu bar. Right. So for that we will, as there is also neutrino, so we will quickly check these conditions. So for L it is minus 1 plus 1 1 minus 1. B 0 0 0 0. Q 1 minus 1 0 0. All the things are fine. Now coming to LE 0. This is 1 1 0. Fine. L mu minus 1 0 0 minus 1. L tau 0 0 0 0. Now you can see that all the things, that means delta L is 0, delta B is 0, delta Q 0, delta Le 0, delta L mu 0, delta L tau 0. Right. So we can have this expression as allowed one. Now mu plus. Now we will draw the Feynman diagram. Nu E nu mu bar. So we will draw the Feynman diagram for that. So what will be the Feynman diagram for here? Mu plus nu mu. Okay, mu plus nu mu bar E minus nu E. And you can see that the vertex here. What will be the vertex here? This is plus 1, this is 0. Then it will be W. This is minus 1, this is 0. Then it is W. That means mu plus E minus going to nu mu bar nu E, that will be mediated by W. Boson solely. It will not be possible to mediate that interaction by Z. So that means our option will be, what is given here, it will be C is correct, that it is fully mediated by W. Now coming to mu plus mu minus goes to E plus E minus. So if I write that one, mu plus mu minus E plus E minus. Quickly we will just check L value. L is minus 1 1 minus 1 1. B, obviously these particles are not boson, so that, sorry, baryon, so that means the B will be 0. Q 1 minus 1 1 minus 1. Fine. Then Le. Le will be what? 0 0, and for here minus 1 plus 1. L mu. L mu is what? It is 1 minus 1 1. This is 0 0. L tau is 0. Then you can see that L, B, Q, Le, L mu, L tau all are conserved in that case. So that means mu plus mu minus going to E plus E minus is allowed. Okay. So now we will draw the Feynman diagram for that. How to do the Feynman diagram? Mu plus mu minus, then E plus E minus. Now coming to the vertex here. Here you can see this is plus 1, this is minus 1. So which one will be the mediator? It will be neutral. That means let's say it is Z. I mean it can also be gamma, but in that question they are asking it is solely mediated by W or not. So it will not be solely mediated by W. The mediator will be Z or gamma. So the fourth option will also not be correct. Yes. Now, which of the following processes are solely mediated by W boson? Correct all. I choose all correct options. The correct option will be A and C. Okay. So these are the case for question number 4. Now we will go to question number 5. In question number 5, it is asking that which of the following statements is or are correct. Z boson can take part in electromagnetic interaction. Both Z and W bosons are massive. Z bosons directly interact with quarks. Gluons mediate weak nuclear interaction. So for that question, I am going to write some note. Okay, in gravitational interaction, the mediator is graviton, right? In electromagnetic interaction, the mediator is photon, which is gamma. In weak interaction, the mediator is W plus W minus Z0. In strong interaction, the mediator is gluon. So there in that universe there are only 4 interactions are there. One is gravitational, electromagnetic, weak, strong. So among these 4 interaction or forces, gravitational interaction is mediated by graviton, electromagnetic is mediated by photon, weak is mediated by W plus W minus Z0, and strong is mediated by gluon. So now coming to the fourth option in that question. Gluons mediate weak nuclear interaction. It is written here. But we already seen that gluons can mediate only strong nuclear interaction. So that means this option is not correct. Okay. Now coming to other questions. Z boson direct. Okay, so we will talk about B option first. Both W and Z bosons are massive. We already knew that the W mass is of the order of 80 GeV and mass of Z is of the order of 90 GeV. That means W boson and Z boson are massive. It is correct. So the B option is correct. Now coming to C option. Z bosons directly interact with quarks. Yes, that is also correct. Because let's say our quarks in any nuclear reaction which is weak under nuclear reaction is, and in that weak nuclear reaction quarks are present. As it is weak interaction, that means that will be mediated by either W plus W minus or Z. So in that case Z can directly interact with quarks, right? So the correct option will be C. Now coming to A. Z boson can take part in electromagnetic interaction. Z boson cannot take part in electromagnetic interaction because it is weak only. That means Z boson is only interacting in weak interaction. So it is not it cannot take part in electromagnetic interaction. So for that question, the answer will be B and C. Okay. So if you have any doubt, then you can ask me quickly. See, because these questions are very simple. Week 12, assignment 12 are very simple. So we can simply answer these questions. Okay, now going to the next question. Select all the allowed reactions below. What are the reactions here? U plus U bar goes to U plus C bar. Okay, and there are four different reactions, and we have to check that which one is allowed. First one is U plus U bar is U plus C bar. U plus U bar is mu plus mu minus. E plus E bar, U bar is going to mu E bar plus D bar. E plus D is going to mu E bar plus U. So we will check one by one. U plus U bar going to U plus C bar. So first of all, in any reaction, in the previous class, in the previous question also, or in the first question also, we were talking about that in any reaction, energy should be conserved. So at the very first, we will check here, energy is conserved or not. Now, energy means, let us take that it is in rest. So that means M of U plus M of U bar should be equal to M of U plus M of C bar, right? Okay, now you can see here, mass of U bar is 1.7 to 3.3 MeV. Similarly, mass of C bar is, let's say, that much. Now, how can we tell that Mu plus Mu bar equals to Mu plus Mc bar? It will not be correct because energy is not conserved here. So, if energy is not conserved, that means this reaction is also not allowed. Right? So, the first option is crossed. Now, come to B. U bar, mu plus mu minus. U bar, mu plus mu minus. So for that case, we will check that L, B and Q are allowed or not. U plus U bar, mu plus mu minus. First of all, L. This is a baryon 0, 0. This is lepton minus 1 plus 1. Then you can see delta L is 0. Fine. What about B? This is baryon, this is anti-baryon. This is not baryon, this is not baryon. So delta B is 0. Q. It has value 2 by 3. It has minus 2 by 3. It has 1, it has minus 1. So delta Q is also 0. Now you can see that L, B, Q are conserved. So that means this process is allowed. So this option is allowed. Now coming to second one. E plus U bar. Mu E bar plus D bar. E plus U bar. Mu E plus D bar. So quickly we will check L. What will be L here? Minus 1, 0, minus 1, 0. Then B. Then you can see delta L is 0. Now what about B? 0, minus 1, 0, minus 1. So delta B is also 0. Now Q, this is plus 1, this is minus 2 by 3. This is 0, this is 1 by 3. Now we will calculate this one. 1 minus 2 by 3. What is the value it is? This is 1 by 3. So if it is 1 by 3 and here also it is 1 by 3. So that means delta Q is also 0. That means the process E plus U bar new E bar, yes, new E bar D bar, this is possible. And also, okay, one more thing is there. If I told that if it is neutrino, that means we will check the weak interaction condition also. So let us check that one. Le. So Le is minus 1, 0, minus 1, 0. Very good. L mu 0, 0, 0, 0, because there is no mu type left arm. It is also not there. So now you can see that L, mu, tau all are independently and separately conserved. So that means this process is allowed. So C is also allowed. Now coming to D. E plus D, new E bar plus U. E plus D, new E bar plus U. Okay, so first of all you can see that there is neutrino. That means it will be weak interaction. So in weak interaction we will check L, dq, Le, L mu, L tau. N minus 1, 0, minus 1, 0. Delta L 0. B 0, 1, 0, 1. Delta B is also 0. Q 1, minus 1 by 3, 0, 2 by 3. Then you can see that delta Q is 1 minus 1 by 3 minus 2 by 3, 0. Now Le. Okay, so Le is here minus 1, 0, minus 1, 0. Delta Le is also 0. L mu is 0, 0, 0, 0. So this is 0. L tau also 0 because there is no tau type left on. So you can see here that for this case delta L, delta B, delta Q, delta Le, delta L mu, delta L tau all are 0. So which tells us that the fourth option, this one, is correct. So in that case B, C, D are allowed. Okay. So this is the case. Okay, so I think it's understandable. If you have any doubt, you can ask me. Okay, so we will go to the next question. A pair of electron and positron can annihilate to produce 2 photons. Is it true or false? So, electron is E minus, positron is E plus. So, E minus and E plus, if it will annihilate, then what will be produced here? E minus plus E plus. It will definitely give 2 gamma photon. Why? You can see here that our lepton, that spin, half, 1, 1. So H1 plus H2. 2, this, right? Similarly, if I write here H1 prime plus H2 prime, 1 minus 1, 2, 1 plus 1, which is 0, 1, 2. Now you can see that the spin is conjugate here, and E plus is E and E minus also, in that energetically this is also possible. E plus E minus can produce mu plus mu minus. So the option A, which is true, is correct one. A pair of electron and positron can annihilate to produce 2 photons. Is true. So now question number 8. In that question number 8, you can see it's very similar to previous one. A pair of electron and positron can annihilate to produce 2 bosons. Is it true or false? In the previous question, it was E plus plus E minus is making 2 photon or not. That was correct. And as I can write here, photon is boson. So E plus plus E minus, this is becoming 2 gamma. That means boson plus boson. So 2 bosons are coming here, right? So a pair of electron and positron can annihilate to produce 2 bosons. That is true. Okay. It is very similar to first one, the previous one, because in that previous one it was told that electron and positron can annihilate to produce 2 photons, and as the photons are also the very bosons, so we can tell that pair of electron and positron can annihilate to produce 2 bosons, and these 2 statements are correct. That means true. So for 7, the option was A. For 8 also, the option is A, which is true. Okay. Now we will go to the last question. Question number 9. Choose all the right answers in a collision of electron and electron. Which of the forces are involved? You can see here there are 3 options: electromagnetic force, strong force, weak force. There is no gravitational force. Obviously there will be gravitational force, and the gravitational force is everywhere present in our universe. So the electron and electron collision, in that case also gravitational force is there. But they are asking which of the following forces are involved in that collision of electron and electron. So first of all, electron. Which are the forces is involving? We will talk about one by one. First of all, it is electromagnetic forces involved or not. E minus, E minus. So in that case, electromagnetic interaction, electromagnetic force will be involved, because E minus and E minus both are charged particle, and this has the charge under electromagnetic charge. So that means electromagnetic force will be involved in this case. Now coming to strong force. Okay, strong force will not be there. Strong force will not be present in the collision of E minus and E minus. Why? Because strong force is only present at the inside of the nucleus, and E minus and E minus, if only these 2 particles are present in that collision, then there is no nucleus, and the nucleus present is means it is a strong interaction. So if there is no nucleus in the collision of E minus and E minus, So strong force will not be present here. Okay. Now coming to weak force. Weak force will be there because it is a lepton. E minus, E minus. So in that case, E minus case, as these are the lepton particles, so that means there will be a weak force in between them. And also let's say if like E minus is there, that means nu E bar is also there, right? So as neutrino is also present here, so that means weak force is always there. So for E minus collision, electromagnetic force is there and weak force is there. There is no strong force. Okay, so that means the answer will be A and C. These are the all total 9 questions from previous year assignment week 12. So I am going to recap it a little bit more. This is the first question. Select all the right statements from below. Photon has 2 independent degrees of freedom, whereas Z boson has 3 degrees of freedom, and this is the correct one. Then in the next class, next question, the process E plus E minus going to W plus W minus, where W plus minus denotes the weak gauge boson of mass 80 GeV by c square is possible with sufficiently large kinetic energy for the electron and positron. This will be the correct one, B, option B. Now coming to question number 3. Particle X decreased to 2 particles A, B, that is X is going to A plus B. If X and A are fermions, B is necessarily a boson due to the spin momentum conservation. Question number 4. Which of the following processes are solely mediated by W boson? Choose all correct options. We have seen that mu plus nu E bar going to E plus nu mu bar and mu plus E minus going to nu E nu mu bar. These two are the correct options. Now question number 5. Which of the following statements is or are correct? The statements are correct is both W and Z bosons are massive. Z bosons directly interact with quarks. Question number 6. Select all the allowed reactions below. U plus U bar goes to U plus C bar. That is not correct. And rest of the reactions are correct. That means U plus U bar goes to mu plus mu minus. E plus U bar goes to mu E bar plus D bar. E plus D goes to mu E bar plus U. And the seventh question is a pair of electron and positron can annihilate to produce 2 photons. That is true. Eighth one is a pair of electron and positron can annihilate to produce 2 bosons, which is also true. Ninth one is choose all the right answers in a collision of electron and electron. Which of the forces are involved? Electromagnetic force and weak force. Okay. So there is one thing what I want to tell you, that there is one class where we will talk about exam related things. Like this is week 12, which is the last week for that course nuclear and particle physics, but we will take another class where we will talk about exam related questions, like not obviously questions but exam related suggestions, and what will be the exam pattern in that exam center, and what will be the marking of each and every questions and all these things. So this will be explained in the next class. And yeah, so it will be like this will be on yes, this will be from 6 to 7. And there will be only one number question, and there will be only like exam related means there will be some topic which we thought that it will be important for the exam, and there will be some questions on some tricky basic questions which can be useful for exam. Okay, so if you have any question you can ask me. Yes, and one more thing, that Google Drive, in that Google Drive I will upload the PPT, no problem. So in that Google Drive you can find the answers as well as the questions. This is the previous year assignment, not this year assignment obviously, as we all did that one previously also. So yeah, if there is no other questions, we will stop today's session and we will meet in that class, and that will be the last class.